What's going on, everyone? Welcome back. Patrick here, and moving on to the next question dealing with the F test still. So Amazon wants to test if the delivery times for Amazon Prime members vary in NYC less than Toronto at a 2% significance level. A sample of delivery times from both cities is shown below over here. So notice in this case, we're not given the sample information, we're given a sample list. So this kind of question is going to be a lot easier to do in the calculator. I'm going to show you how to do it both ways though, manually and then with the calculator. If you're doing this manually, the first thing you got to find out is what is the sample size, right? Taken from both of these populations, and then also what is the standard deviation of both populations, or the sample variance. But let's just find out the sample standard deviation. So here, notice that there are 12 items, right? In this sample, or 12 observations. So this N1 here is 12. And I've gone through videos before where we can calculate that sample standard deviation manually. I'm not going to do it in this video as it's going to take quite a while. But if you were to calculate the sample standard deviation of this, it would be 4.84. Right? And then here, how many observations are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So N2 would be 9. And then if you were to calculate the sample standard deviation here, you would end up getting 9.81. So notice that NYC, we let that be population 1, and then Toronto, we let that be population 2. So if we set up our null and our alternative hypothesis, what are they going to be? Well, notice that we're testing if the delivery times for our Amazon Prime members vary in New York City less than Toronto. So we want to check if that population variance for population 1 for NYC is less than the population variance for population 2. So that's the alternative hypothesis. So the null hypothesis would just be the opposite of that. So notice here that with how the null and the alternative is set up, we are working with a left-tailed test. Right? And notice that this region here has an area of 2% because we're dealing with a 2% significance level. So over here in this area, in this region, we would be rejecting the null hypothesis, and then in this area, we'd be accepting the null hypothesis. And so what we got to do now is we have to find this critical value. So when we're using an F distribution, there's 2 degrees of freedom, right? There's one for the numerator and then one for the denominator. Notice in this case that the numerator, it's population 1, it's NYC. So the degrees of freedom would be N1 minus 1. So 12 minus 1 would be 11. And then the degrees of freedom for the denominator would be population 2. So it would be 9 minus 1, which would give us 8. And if you want to find that critical value multiple ways, you could look it up in the F table. You could also use the calculator. So you'd go through this series over here. When you get to this input screen, the data would be variable. The area, it's always going to be the right-tailed area. So notice if this is 2%, then this area here is 98%. So this would be 0.98. The degrees of freedom of the numerator would be 11, and then the denominator would be 8. And if you execute that, you would end up getting 0.2556 for the critical value. So that would be over here. Now, what if you look this up in the table? Then it's a little bit more complex. What you would have to look up first is that upper critical value, where this would be 2%. However, you would have to swap the degrees of freedom. If you remember, I went over that in the overview video. So you would have to look up this area being 0.02, right, that right-tailed area, but then you'd have to swap these. So the numerator, degrees of freedom, would be 8, the denominator would be 11. And then when you do that, you would end up getting 3.9119. And then what you do is you take 1 divided by 3.9119. And you'd end up getting 0.2556, right? So it's a little bit more complex if you do it manually. But if you're just using the calculator, all you have to do is plug in that whole right-tailed area of 98%. You don't have to worry about swapping degrees of freedom. You don't have to worry about finding an upper critical value first. So once you have that critical value, then all that's left to do is to find what that F, test statistic, is. And that's equal to what? It's equal to, actually, sorry, it's not population, it's the sample variance from population 1 over the sample variance of population 2. Well, notice we're given the sample, or we found the sample standard deviation, so it'd be 4.84 squared over 9.81 squared. And when you do that calculation, you would end up getting 0.2434. That would be the test statistic. So on this diagram, where does 0.2434 fall in relation to that critical value 0.2556? Well, notice it's to the left of it, right? This is a smaller number than this one. So the test statistic falls right here on the diagram. And so notice we are in that rejection region. So we are rejecting the null hypothesis. And what that means in this context is that there is evidence pointing towards the times, the delivery times for New York City varying less than Toronto, right? So we are rejecting this null hypothesis. There's evidence pointing towards the alternative hypothesis, right? Where that population variance of NYC, the delivery times for NYC is less than the variance, the population variance for the delivery times in Toronto, right? So that's how you do it manually. And if you're to do all of this with the calculator, you'd go through these inputs here. So you got stat, you would input the two lists, right, in the chart. So population 1 would go under, or sample 1 would go under list 1, sample 2 would go under list 2. And then we're still doing a test, we're doing an F test, and then the data here, instead of putting variable, we're now going to be referring to sample lists. This here, always based on that alternative hypothesis, so you would put the less than sign here. And then list 1 would refer to sample 1, and as long as you put this under the list 1 column, then here you would also put list 1. And then list 2, right? They're asking what is sample 2? Well, sample 2 is coming from list 2. And then the frequencies, you would just put 1 here. And then when you execute that, you'd get a bunch of information, including the standard deviations, right? So that's another way you could find out the standard deviations quickly if you want to. You would end up getting these numbers, but the most important numbers is you would get that F test statistic being 0.2434. What we got before, right? This value over here. And then the p-value you would see would be 0.0168. Right? So if we look at the test statistic compared to the critical value, notice that it falls here, right? So we're rejecting the null. Or if we want to look at the p-value, compare it to the significance level of 2%, notice the p-value is less than the significance level. Whenever that happens, we are rejecting the null. So whichever way you do it, you're coming to the same conclusion. We're rejecting that null hypothesis. So there is evidence saying that the delivery times in New York City vary less than the delivery times in Toronto. Now, one more thing I want to mention is you could have also made this be a right tail test, right? So we could have had a rejection region of 2% over here, and then 98% over here on the left tail. And that would happen if you made Toronto be population 1, because notice that that standard deviation is greater. If you remember in the overview video, I actually like to do it in a way where I'm putting the higher variance or the higher sample standard deviation as population 1, so that test statistic is greater than 1. So then I could just compare it to that upper critical value. So if you were to do it that way, what you would do is you would actually, in this input screen, you would switch these two lists over here, right? Because this ends up being population 1, this ends up being population 2, and then you would switch the alternative hypothesis, right? Because if this is population 1, and we want to test if the delivery times vary less in NYC, that's the same as testing if the delivery times vary more in Toronto. So you would switch, this would be list 2, this would be list 1, and then you would switch the sign to greater than. And you'd actually end up getting the exact same p-value, 0.0168. And then comparing it to that same significance level of 2%, you would be rejecting that null. So there would be evidence pointing towards that alternative, that the times vary more in Toronto, which is the same as the times varying less in NYC. So hopefully that wasn't too confusing, but either way, you don't have to necessarily pick the sample with the higher variance or standard deviation to be the first sample. You could do it this way that I did as well. Either way, you're going to get that same p-value.